100 years since the RAAF was formed, they're now turning their focus to space. Australia getting a space command. 2i Borisov caught on video 2 years after it crossed into our solar system. And astronomers reckon we've got a pretty sweet spot to live in the Milky Way. It's week 14 of 2021. Let's get into it.
On Apple Podcast, Spotify, Google Podcasts, and YouTube. With the latest science and space news, this is Talkin Science with Dr. Brad Tucker and Matt Miller.
Welcome to Talkin Science. Matt Miller with you in Studio 4. Dr. Brad is here as he is every Tuesday for Talkin Science. Brad, happy Tuesday.
Yes, and it's April Tuesday. Scary.
It is very, very scary. Well, it was a special 2-episode week of Talkin Science interviews last week. My chat with Michael Davis AO is online now. He's the chair of the Dr. Andy Thomas Space Foundation, who held the Space Forum last week. They're already planning for the next one in 6 months' time. Hopefully I can get to this one.
Yeah, look, we'll see. They're always rolling them out. So not a surprise the next one's already in the works.
Absolutely, it is brilliant. Well, before we get into the show, a quick reminder of the socials. We can find you on Twitter at btucker22. I'm on Twitter at Miramat86, Trekzone on Twitter and YouTube, of course, and your favourite podcasting app of choice. Brad, let's get into the show. And first up, Ingenuity has been dropped onto the Martian surface ahead of its historic flight.
Yeah, this was they've been gearing up, as he said, for this flight next week. Part of it, essentially the tricky bit, well, one of the many tricky bits was dropping it under Perseverance, which essentially has been shielding and protecting and keeping it warm and allowing it to be exposed to the Martian environment, which gets obviously very cold. And that's a test of batteries and electronic operation. So surviving that first night was another huge milestone. Now they'll start recharging, getting to that full 100% charge and gearing up for a flight next week.
Well, the first commercial crew port relocation has been completed on the space station ahead of the next crew, Expedition 64, arriving at the end of the week.
Yeah, a little bit of a shuffling the card game, but really shuffling the space capsule. And we'll have 3 now at the end of this week, capsules docked at the space station, 2 of them belonging to SpaceX. So a remarkable feat to get there. And the space station will be very, very crowded with another 4 astronauts joining them, bringing the total to 11 later this week.
Very, very exciting times for the space station and pretty busy up there as well. Well, let's get into our stories of the week. And Air Marshal Mel Hupfeld has confirmed that a truly integrated space domain organisation, that's his words, is on track to be established next year.
This is probably long overdue. In fact, he says it's long overdue. But when we look at space forces, we've talked about Russia, China, Japan, France, I think the UK, they've all developed or developing their own equivalent space forces, let alone something Space Command. The difference here is not just a dedicated new branch of the military like Space Force is, but something just to coordinate and control the operations existing in the other 3, in this case, Army, Navy, Air Force, and Australia. Something that when you see how space is being involved and used in defense, clearly something that is needed in the way it's headed with the use of space and defense.
Well, hopefully we can come up with something better, a name better than Space Command, and the Starfleet logo that the United States is using. But as the Air Marshal said, it's going to be a joint command staffed by Army, Navy and Air Force personnel. So truly an integrated unit of the Australian Defence Force.
Yeah, because they do all have their own operations, they have their own technology, they have their own people. And so the name of the game here is not necessarily to replace anything, but making sure, the left hand is talking to the right hand, and the left hand is actually doing similar or different things to the right hand and not just duplicating work. And yes, they do talk, but it's a little bit easier to just be under the same reporting structure so that it immediately goes on instead of 6 months down the road realizing, oh, we could have just talk to the Navy and dealt with this. And it also means strategically funding and development, not just the coordination and operations. You can accelerate these things faster. And, it probably is a bit overdue. genuinely, especially how we've seen it develop, not just in other countries, but the private space sector as well here in Australia.
Well, we're not aiming to be a competitor in space, a militaristic power, but rather a defensive organisation, and maybe a little bit of space cop work as well, with Air Marshal Hupfield saying to the ABC that we'd be pointing out other countries doing the wrong thing, and companies as well, basically policing the Earth's orbit for the betterment of science.
And this has always been one of the arguments of when we talk about Australia and New Zealand. Geographically, we kind of cover a sixth of space. If you think about where we are, between South America and Africa, there's a huge gap in the world that, yes, there's obviously the Pacific Islands, but in terms of the bulk of the brunt of it, it's Australia and New Zealand. So likewise, that policing nature, we kind of have a sixth of the seat of the table, so to speak. Where other countries, even though they may be more developed or more powerful or spending more, they don't police as much area. And there's been this argument from lots in the community, myself included, saying, well, naturally that is governing, and it already is a bigger voice than necessarily our spending, or as you said, our more operational involvement. And I think this is the great thing that Australia is carving out to say, this is the good thing that we do. People are already calling on us to do this. People are already asking us to do this. So it's now just heeding that call, so to speak.
Well, next up, interstellar comet 2I Borisov, which crossed into our solar system a couple of years ago, has revealed some more about itself.
Yeah, Borisov was, we talked a lot about Oumuamua last week. Well, Borisov was the second interstellar object. But the difference with Borisov was when it was viewed and observed, it just clearly was a comet because it was a comet. You could see it. It had a beautiful tail. And also because it was spotted a bit earlier, and we clearly clued on to what it was, so to speak, a lot of work was put into understanding what it was. And so there's a lot of new detail showing our understanding of this material from Borisov, and realizing that, in fact, Comet Borisov, the gas and the elements on it, is what we call very pristine. It's not heavily evolved. It's not heavily changed. It is essentially unaltered, most likely from its birth.
Well, as you say, this is only the second interstellar object after Oumuamua. I had my question here, and you beat me to it. As you say, it was the only the second object that we found, and I wanted to point out that last week all the supers and all the graphics that I had up called it an intergalactic comet or an intergalactic object. It clearly is not that. It didn't come from another galaxy. It's interstellar. It's come from somewhere else in our galaxy, which is equally just as exciting.
I mean, there is the off chance it could be intergalactic. To be fair, we don't know, right? And I think this is the mysterious thing. Statistically unlikely, given the distances. Most definitely interstellar. But I think this is the exciting thing. It is not from this solar system. And this is why these recent studies of studying Borisov is exciting, because you can get a glimpse of what material was present when whatever star system it came from was created, just as we like to study these things in our own solar system. That pristine material it's kind of like seeing the ingredients that go into your cake. And if you want to know what your cake's made up of, you want to see the ingredients. But if it's already been changed or baked or half eaten, in the case of our solar system, you don't really get to understand what went in it. And this study has shown that, well, Borisov clearly shows signs of the beginning ingredients into that solar system's formation.
Now, I'm going to be chatting with both of the teams who have released papers on Borisov in the coming weeks, diving into the techniques on how they were discovered. But it's certainly a fascinating object to watch as it gets drawn into our sun. As you say, with that pristine element, that really means that, and as you were saying, it hasn't been burnt up by a sun, changed or radically altered. So it's a really fascinating one to study, and we've got it on video now as well, which is even more exciting.
Exactly. Lots of detail. So you get to see, the nucleus, its tail, and that gas coming off of the nucleus, which makes up the tail, and using a lot of the techniques from the VLT, the Very Large Telescope in Chile, able to really see the chemical or the elemental composition of this object. And that makes it quite exciting. And it's just, we talked about this a few months ago, this idea that if there are quite a few of them out there, to build a dedicated mission, potentially kind of wait and see when the next one appears by and kind of hop on it as it comes by.
And lastly, this week, Brad, astronomers reckon we've got a pretty sweet spot to live in the galaxy.
Look, it's good to have a sweet spot. And in this case, a sweet spot means a safe spot. And this is something that people have talked about and studied for actually quite a bit about what are the areas in the Milky Way. And what we mean by that is we know there are patches that are denser areas of stars, and also the denser the age of the stars, the types of stars, younger stars or bigger stars really will blow up quicker than smaller and potentially older stars. And finding these areas, because when a star blows up, you don't want to be near it. And there's clearly a relationship here between the pockets in a galaxy where star formation is occurring, as we say, and really supernova occurring, and the potential habitability of those places. You don't want to be in a place where there's lots of stars blowing up that's going to produce huge amounts of radiation, in addition to the shock waves and everything like that. That will not be conducive to life. Conversely, if you're completely in a very empty spot, there's not enough ingredients to form it. So you want the right balance between having some stuff and safe, but enough stuff to actually form things, but not too much. So a mapping of the history of our Milky Way has shown where, if you're going to buy real estate in our galaxy, where is the place to build it?
Well, we talk about the Goldilocks zone for black holes, their formation. I guess this is really about galactic Goldilocks zones for real estate, finding that right balance, not too hot, not too cold, in terms of blowing stuff up, deadly gamma rays and all the rest of it that can really harm a civilization's chances of evolution.
Yeah, look, and we do know that with some supernova, they can affect things up to a couple of hundred light years. The exact boundary really depends on the size of the star, how big or how young that star is, how much energy it has. So you want to be relatively padded away from other nearby stars, but again, enough in the history that they've actually created the elements to form solar systems to provide life. So it is that Goldilocks zone of a galaxy, and we have a good history or ability to trace back some of the previous explosions in our Milky Way, both based on how galaxies form and stars evolve. And just like everything, depending on when you are in the galaxy, depends on where you want to live. Where we are now is relatively safe, but in the past, you probably want to be more towards the edges, where it's a little bit quieter. But when the new neighbors come in, you may need to migrate to a different part of the neighborhood. And it's exactly what they're finding, that it depends on the time where you want to live. And obviously now we're in a good place to live.
Well, the Italian astronomers that did this research looked back over around 11 billion years, and the results, as you say, the edges of the galaxies, the Milky Way's edges, were a pretty safe bet in the early development of our galaxy.
That's right. But then, as we know, as other galaxies get pulled in, you get a lot of turbulence, and you get a lot of star formation, triggering young stars that live quickly and explode, producing all of that radiation and gamma rays. So you want to let it evolve over time, and that means you eventually want to migrate. You want to move. You want to find a spot and then move over time. And we do know pockets of stars do this, and so now the inner parts of the galaxy, like where our sun and our solar system is safer. But even still, it depends on exactly which part. And a lot of people point to this is just as important to the question of habitability as you said the Goldilocks zone is for the actual star system. It's one thing to figure out where your planet is relative to that star, but you also need the entire star system to be able to survive and evolve without a nearby star exploding or producing lots of radiation. So there's lots of pieces of the puzzle to finding places to look for life, understanding where life could evolve. And so it's a complex question. You don't just find the planet, you have to find the whole neighborhood as well as what they're pointing at.
Well, this research is going to aid exoplanet hunting missions like TESS to indicate where they should be pointing. And I guess it's sort of the neighborhoods that aren't making too much of a racket, universally speaking.
Exactly. You want a little bit of a quieter neighborhood, a nice place, a little bit quieter, more serene. But also, you don't want such that the stars themselves are too old and cranky, what we call the M dwarfs, which produce lots of flares themselves in radiation. So it really is finding that right balance. And these sorts of things will help shape, or as you said, our searches for not just planets, but the habitable planets that then we can go focus on to look for signatures of life.
Well, before we go, Brad, a quick plug for the next Talkin Science interview. Colonel Mark Vanderhei beamed in from the Baikonur Cosmodrome a couple of weeks ago ahead of Expedition 64's launch this weekend. How do you prepare for launching into orbit and spending such a long duration on the space station?
Oh, I think you just have to pay attention to your mental health. I think for me, spending some time meditating every day, trying to figure out ways to help out other people is a great way for me to feel happy with myself. So just having a sense of service about every day and trying to feel like you have a way to contribute to the rest of the group that's useful will go a long way towards making it a very enjoyable time period for me.
So be on the lookout for that one Thursday at 12:30 p.m. GMT, or if you are watching this episode a little later in the piece, you can click the card in the top of the YouTube video or find it on the Trekzone website as well. Brad, another big day, another big week even of Talkin Science. Looking forward to picking apart the stories of the week with you again next week.
Sounds good.
Keep up to date with Twitter. Catch new podcasts daily on YouTube. Plus, we're beaming to your favorite podcast app 5 days a week. Just search for Trekzone and subscribe.